Dear students, in the last class we have seen big O notation problems, and big O notation is for the worst case complexity of an algorithm that we have seen in the last class. Now we will continue with another notation that is called as omega notation, and it is for the lower bounds, and it is for the best case complexity of an algorithm. Okay, remember, big O notation is for the worst case algorithm, and omega notation is for best case complexity of an algorithm, and it represents the lower bound of the running time of an algorithm. And here you can see, if for the n value, fn is equal to omega gn. Okay, this is fn function, and this may be the input omega c into gn, that is constant into gn. So both are represented here. Omega gives the lower bound of a function, and it is represented in this way: omega gn equal to fn. There exists positive constants c and n0 such that cgn less than or equal to fn, that means fn and greater than or equal to 0. cgn less than or equal to fn and greater than or equal to 0 for all n greater than or equal to n0. So we can describe the above expression as function fn belongs to the set omega gn. You can see here, this is represented as set, and a function fn, since it is represented as one set, function fn belongs to the set omega gn if there exists a positive constant c such that it lies above cgn for sufficiently large n. That means sufficiently large value, n means large n value, and for sufficiently large n value it lies above cgn. Okay, for any value of n, the minimum time required by the algorithm is given by omega gn. For any value of n, the minimum. So in the big O notation, we will say maximum time required, and here minimum time required by the algorithm is given by omega gn. And another one is theta notation. This theta notation encloses the function from above and below, since it represents the upper and the lower bound of the running time of an algorithm. Remember, so in this omega notation is for the lower bound of the running time of an algorithm, and theta notation is for the upper and the lower bound of the running time of an algorithm. It is used for analyzing the average case complexity of an algorithm. Theta notation is for average case complexity of an algorithm. So in this above expression, we can describe a function fn that belongs to the set theta gn if there exists positive constants c1 and c2 such that it can be sandwiched between C1gn and C2gn. Here you can see Fn, this belongs to theta gn if there are positive constants C1 and C2 and n0 such that Fn is greater than C1 of gn and less than or equal to C2 of gn for all n greater than or equal to n0. If a function fn lies anywhere in between C1gn and C2gn for all n greater than or equal to n0, then fn is said to be asymptotically tight bound. Remember, if function fn lies anywhere in between C1gn, Okay, that is the first input or minimum input, and the large input C2Gn. For all n greater than or equal to n0, then Fn is said to be asymptotically tight bound. When we say tight bounds, we mean that the time complexity represented by the big theta notation is like the average value or range within which the actual time of execution of the algorithm will be. So that means when we say tight bounds, the meaning of that one is it will take the average time complexity to execute the or to represent the function. That's the concept of big data notation. Now I'll start with chapter 2, that is fundamentals of algorithm with problems. Here I'll try to explain all the concepts with problem. Okay, all the algorithm problems. First we will take swapping. As you know, swapping means exchanging the value from one variable to another variable. If the problem given is two variables a and b, and we have to exchange the value assigned to them, make the assumption a is equal to 10 and b equal to 20. Then we will call it as a initial configuration, that is initialization. And want a equal to 20 and b equal to 10. That means we want to swap the values. That is our target. That means output. Now we can use assignment operator. Okay. And a equal to b causes copying of the value stored in a into b. Okay. Directly if I copy b value into a, then b value will come to a. So then even the b contains the same value, a contains the same value. If we do a is equal to b and b equal to a, what happens? If a equal to b and b equal to a, if a equal to b and b equal to a, so then there will be a same values again. Okay, and this may be a problem. And for that purpose, we will take one extra variable. Here you can see. We will use temporary variable t. Now, t equal to a, that means temporarily we will take the a value into one new variable called t. Now, t gets the value of a, then a equal to b, a gets the value of b, and then b gets the value in t, that is nothing but a. So in this way, we will do the swapping process. So this is the first concept. So we can use the assignment operations for the swapping purpose. Second problem may be counting. Given set of n students who have marks in the range 0 to 100 in one course, the pass marks in the course are 50. Find how many students have passed the course. The problem is given set of n students who have the marks, we don't know, n may be 5, 10, maybe 15 or 100. And they can take the marks from 0 to 100. Okay, the pass marks in the course are 50. How many students have passed the course? That we have to find out. So for one student, input marks of the student. If the marks of the student greater than pass marks, the count of students passed is equal to 1. Otherwise, the count of student passed is equal to 0. So in simple way, we can say that if I take one single student, if single student marks I have to take, and that marks I have to compare with the pass marks, and then I can say one student is passed. I can increase the count as 1. Okay, so we will see the process. The counting process, maybe for n students, we need to repeat the process and update the count. We need to repeat the process and update the count. This can be achieved by using a loop construct such as while. Even you can take for, while or do while. First, we will take count is equal to 0. Initially the count of students who have passed is 0. Count is equal to 0. M is equal to 0. M is a variable that gives the number of students for whom marks have been processed. Okay. If any student's marks are processed, we will take it in the M. M is a variable that gives the number of students for whom marks have been processed. So while M less than N, do M equal to M plus 1. Okay, M less than N, then M equal to M plus 1. That means number of students are 5. Then I have to process all 5 students' marks. That's the concept. And the passing marks may be 50. And I have to process all those n number of students. And I can keep track of those students by using M. I can keep all the passed students in C, that is count. Okay, in the count. So that's the concept. While M less than N, do M equal to M plus 1, input marks of the current student. If marks greater than or equal to 50, count is equal to count plus 1, then end while. Repeat the same process for the another student. Okay, if you have marks greater than or equal to 50, then count equal to count plus 1. Increment we will count. Then at the end, we can display the count. Okay, this may be a concept of solving this problem. Next concept is summation. We have seen assignment and then counting, and third concept, okay, maybe the summation. The problem may be given a set of n numbers, find the sum of these numbers. Given set of n numbers, find the sum of these numbers. Let the n numbers be a1, a2, a3, so on, an. Okay, there are set of n numbers. You have to find the sum of these numbers. Given numbers are, we don't know which numbers those are. So for that purpose, we are taking it as a a1, that is number 1, number 2, number 3, so on, number n. Resulting sum is a1 plus a2 plus a3 plus so on plus an. For first two numbers, sum is equal to a1 plus a2, correct? For first two numbers, sum is a1 plus a2. The third number, a3, can be added into the sum. Sum is equal to sum plus a3. Okay. Then again, similarly for next number, sum is equal to sum plus a4. So that means we are go on adding the number with the sum. That is the concept of the summation. We will see how we can do it by using programming way. Okay, we will take algorithmic method. Sum equal to 0. So there is initial value of sum. Input n, that is total number of numbers to be added. Okay, input n value. If there are 10 numbers to be added, take n as 10. 20 numbers has to be added, take n as 20. I equal to 0. That is to keep track of the numbers. I is equal to 0. So it is called as loop index. While I less than n, do the process. While I less than n. For the first time, I is equal to 0. So 0 less than n. I have taken n as 5. Then I equal to 0 while I less than n. Okay. So the 0 is less than 5. So I equal to I plus 1. So count I as 1. That means one number is added. Okay. Input AI. So since we are doing the process first time, input one number and add that number to sum. Sum is equal to 0 plus that first number what we have taken, and repeat the same process for all the 5 number. Next time I may be 1, next time again I may be 2, next time I may be 3, next time I may be 4. Since it is less than n, till 4 it process and it displays the sum. Okay, this type of concept we will call it as a summation process. Even though You know these concepts in the C programming, but in the algorithmic process, we will see all the process one by one. Next concept is factorial, finding the factorial of given number. Problem. A given number n, compute factorial, that is given numbers factorial. It may be represented as n exclamatory symbol, where n greater than or equal to 0. Since, as you know, if the n value is 0, the factorial may be 1. We know n factorial is equal to 1 into 2 into 3 into so on n minus 1 into n. That means if it is 5, 1, 2, 3, 4, 5. So since 0 factorial is equal to 1, as I said, if n is 0, we will take it as a 1. 1 factorial is again 1. 2 factorial is 1 into 2. 3 factorial is 1 into 2 into 3. And n factorial can be computed as n into n minus 1 factorial. N into n minus 1 factorial. So for example, the factorial of 5 is nothing but 5 into 4 factorial. Okay, 5 into 4 factorial. That is 5 into 4 into 3 into 2 into 1. We will see the programming approach. Input n value and we will take factor is equal to 1. For I is equal to 1 to n, do factor is equal to I into factor, okay, and repeat this process up to n, output the factor, okay. This is how we will take the approach, okay. And here this statement is counted as one statement, okay, and it may be ON. Thank you, students. In the next class, we will continue with other problems. Thank you. God bless you.